Doing? I want to believe you are enjoying your break. I trust God that very soon this break will be over and we're back at school. Before we went on break, we were on sulfur and its compound, and we talked a lot on hydrogen sulfide, sulfuric acid, and several other compounds of sulfur. We'll be looking at types of reactions, types of chemical reactions. At the end of this lesson, by the end of this lesson, you are expected to be able to state and define the types of reaction. You should be able to define redox reaction, and you should be able to distinguish between oxidizing and reducing agents. As chemists, you should understand what chemical changes are. The understanding of chemical changes will enable you to fully understand what chemical reaction really is. Chemical changes are changes in which new substances are formed. From your elementary chemistry, that means your chemistry in SS1, you were told that physical changes, new substances are not formed, and you can easily get your original product, your original substance. But in chemical changes, new substances are formed, and you cannot get the original substance. That is called a chemical reaction. And these new substances are called products. I mean, the new substances formed after a chemical reaction are called products, while the substances that undergo the chemical reaction are called reactants. Therefore, the reaction between the reactant and the product is actually called chemical. The reaction between the reactants is actually called chemical reaction. There are several reactions in chemistry. In fact, your understanding of chemical reaction will help you to really understand what chemical processes are. Let's look at the different types of reactions one after the other. I'll start with combination reaction. As the name implies, combination. Two things coming together, they combine to form a new substance. This is a reaction in which two or more substances, they combine to form one single compound. Two elements, element A combines with element B to form a compound. As you can see, mercury reacting with chlorine to form mercury chloride. You can equally have iron reacting with sulfur to form iron sulfide. You can equally have sodium reacting with chlorine to form sodium chloride. Another type of reaction is displacement reaction. Displacement. That is, an element will be displaced by another element. Element A reacting with element BC. That means the element A will take the position of element B on the product side. As you can see here, the reaction between zinc and copper tetraoxosulfate 6. In the product, you would have seen that the zinc had displaced the copper. The zinc is now taking the position of the copper to now give us zinc tetraoxosulfate 6 and copper. Another reaction is decomposition reaction. When something decomposes, that means something breaks down into simpler substances. This involves the splitting of a single compound into two or more simpler substances. We can have calcium triisocarbonate 4, splitting or breaking down into calcium oxide and carbon 4 oxide. We can equally have lead 2 triisonitrate 5, splitting into lead 2 oxide, nitrogen 4 oxide, and oxygen. In this reaction, a bigger substance or a bigger compound breaks down to form simpler substances. We equally have double decomposition reaction. In this type of reaction, the reactant decomposes to form new substances by an exchange of radicals. This is usually used in the preparation of insoluble salts. What happens here is this: they exchange their radicals. As you can see, an example is elements compound AB reacting with compound CD. They exchange their radicals to form compound AD and compound CB. You can see here barium chloride reacting with sodium tetraoxosulfate 6. After the exchange of their radicals, it now gave us barium tetraoxosulfate 6 and sodium chloride. Another type of reaction is catalytic reaction. This is a reaction that is usually catalyzed by a catalyst, or we say a reaction that uses a catalyst. What is a catalyst? A catalyst is a substance that alters the rate of a chemical reaction. Biologists will say it speeds up the rate of chemical reaction. In chemistry, I like to say it alters the rate of chemical reaction. There are several reactions, that use catalyst in chemistry. An example is in Haber process during the production of ammonia from nitrogen and hydrogen. The catalyst used there is iron. While in the preparation of margarine from vegetable oil that uses hydrogen as a catalyst, even the preparation of oxygen using manganese 4 oxide, there are other several reactions that use catalysts. Another example is another type of reaction is reversible reaction. As the name implies, reversible. That means a reaction that proceeds forward and also proceeds backward. That means it goes forward under suitable conditions, it equally goes backward. An example is this: the reaction between calcium triisocarbonate 4 plus water and plus carbon 4 oxide to form calcium hydrogen triisocarbonate 4. This reaction can equally proceed backward. Calcium hydrogen triisocarbonate 4 under a suitable condition can go backward and form calcium triisocarbonate 4, water and carbon 4 oxide. Another type of reaction is thermal dissociation. The word thermal there actually means heat. That means this type of reaction is usually, energized by heat. This involves splitting of a substance into 2 or more molecules by the application of heat. Once heat is applied, the bigger substance splits into smaller substances. Another example type of reaction is redox reaction. Redox reaction from 2 words, reduction and oxidation. The 2 reactions are opposite each other, yet they complement each other. That means when one goes forward, the other one goes backward, and they have different definitions. Let's start with oxidation reaction. In fact, the 2 reactions can be defined under 4 headings. These 4 headings are, addition of oxygen, removal of hydrogen, loss of electron, and the one that has to do with electronegative and electropositive elements. Let's start with oxidation. Oxidation reaction is a type of reaction that involves the addition of oxygen. It also involves the removal of hydrogen. It also involves the loss of electron, and also involves the addition of electronegative elements or the removal of electropositive elements. Shim, are you listening to me? Alright, how about reduction? Reduction is the opposite of oxidation reaction. Because in reduction, there will be a removal of oxygen. Do not forget that in oxidation, we said it involved the addition of oxygen. Precious, did you get that? Alright. But in reduction, there will be removal of oxygen, there will be addition of hydrogen, there will be gain of electron, and there will be the removal of electronegative elements or the addition of electropositive elements. Hello, ma, I believe you understood what I just said. I gave a distinct, difference between reduction and oxidation. Reduction has to do with gain of electron, while oxidation has to do with the loss of electron. If you really want to understand oxidation and reduction very well, you must also understand the agents that enable this, that enable the reaction to actually, take place. Reducing agents and oxidizing agents. They are the agents that energize oxidation and reduction. Reducing agents. This is a substance which undergoes oxidation and it gets oxidized. Do not forget, a reducing agent undergoes oxidation and gets oxidized, while an oxidizing agent undergoes reduction and gets reduced. However, did you get that? Oxidizing agent undergoes reduction and gets reduced, while a reducing agent is the substance which undergoes oxidation and gets oxidized. There are several examples of redox reaction illustrating reducing and oxidizing agents. I want you to follow me as I show you some of these equations, and you'll be able to identify reducing agent and oxidizing agents in any reaction that you come across with. Let's start with the addition of oxygen. I'm using magnesium and oxygen as an example here. The reaction between magnesium and oxygen gives us magnesium oxide. Looking at this reaction, which one is the reducing agent? Which one is the oxidizing agent? Like I told you, once you see a reaction or an equation like this, if you want to be able to really differentiate between reducing agent and oxidizing agents, victory, you should first look at the equation and identify maybe be two elements. Check out, is there oxygen in this equation? Is there hydrogen in this equation? If there's no oxygen, look out for hydrogen. If there's no hydrogen, check, is there a loss of electron or gain of electron? If none of this, if either of these three, they are not there, look out for electropositive elements or electronegative elements. Now, if you look at this reaction between magnesium and oxygen to form magnesium oxide, you will see that there is oxygen in that reaction. And once you see oxygen, the first thing is for you to identify which one is oxidation and which one is reduction. And I earlier told you, the substance that undergoes oxidation is the reducing agent. How do you know this substance has undergone oxidation? There will be addition of oxygen to it. Looking at this equation, you will see that magnesium here initially, it did not have oxygen. By the time it got to the product side, oxygen had been added to it. That means in this equation, magnesium is the reducing agent, while oxygen is the oxidizing agent, because magnesium had oxygen added to it. The second equation here between iron and water, you will see that iron is the reducing agent. Why? Because iron, by the time it got to the product side, iron had oxygen added to it. Is that understood? The other example is the removal of hydrogen. Like I told you, you check out for oxygen, you probably check out for hydrogen. You can see a reaction between hydrogen sulfide and chlorine to give us hydrogen chloride and sulfur. In this equation, hydrogen sulfide is the reducing agent. How do I know it is the reducing agent? Hydrogen sulfide, by the time it got to the product side, sulfur lost its hydrogen. And when there is a loss of hydrogen, it is oxidation. And the substance that undergoes oxidation is the reducing agent, while the substance that undergoes reduction is the oxidizing agent. Therefore, chlorine is the oxidizing agent. Another example here is the one between electropositive and electronegative elements. Like I told you, once you check out for hydrogen and oxygen, you just move straight to either positive or negative elements. Reaction between sodium and bromine to form sodium bromide. There's no hydrogen here, there's no oxygen. What do I look out for? The negativity of the elements. Sodium reacting with bromine to form sodium bromide. Sodium there is an electropositive element, while bromine is an electronegative element. So you can see that sodium is the reducing agent. Why? Because by the time it got to the product side, it had lost the electronegative element, while bromine remains the oxidizing agent. And for loss of electron and gain of electron, you can see an equation here between iron 2 chloride and chlorine to form iron 3 chloride. Iron 2 chloride there is the reducing agent, while chlorine is the oxidizing agent. Why? You will be wondering, iron 2 chloride, you will think it has gained electron. No, it has not gained electron. Iron 2 chloride, initially iron 2 chloride. After undergoing that reaction, it became iron 3 chloride. That means initially it lost 2 electrons. After the equation, it has lost 3 electrons. Loss of electron, that is oxidation. And do not forget, I told you earlier on that the substance that undergoes oxidation is called reducing agent, while the substance that undergoes reduction is called oxidizing agent. And woman, did you get that? And before I end this class today, I'd like to place a distinction between reducing agent and oxidizing agent. I'll just show you some examples so that when you come across them in your exams, classwork, and tests, you will not be surprised. So these are some examples of reducing agents and oxidizing agents. Reducing agents here we have sulfur 4 oxide, hydrogen sulfide, potassium iodide, iron 2 salt, while oxidizing agents, oxygen, acidified potassium permanganate, acidified potassium heptazodichromate, concentrated acid. This will be concentrated sulfuric acid or concentrated nitric acid. I want to believe you have been blessed. I want to believe you have gained, you have learned types of reactions. You can differentiate between oxidation and reduction. You can equally differentiate between reducing agents and oxidizing agents. Before before the next class, I've given out some assignments here. You will look at these two equations and tell me the reducing agent there and the oxidizing agent, and justify your answers. Why would you say this one is reducing agent? Why would you say the other one is an oxidizing agent? You also list out two gaseous reducing agents. When we come next, we'll look at strictly how to, how to balance redox reaction. Thank you so much. Till then, I love you.